the Orbitals of the Atom Lab. And in it, we're simply going to build a model of various elements, atoms of various elements, using this kit. And in the kit, we've got a red circular piece of plastic with some slots in it. We have a base. We have a wooden stick that will support the atom. And I'll show you how to assemble that. We have a crossbar that will sit on top of the stick like this. We have a smaller blue circle, and then we have several teardrop-shaped orbitals that are to represent the p orbitals. We've got green coloration, yellow, and lastly, pink. And the very last piece are the electrons, small plastic black dots. And the idea of this lab is that we're going to just represent the atom and its orbitals in a way that we can. This is a limited model, but it's a way to get hands-on with understanding model construction. So the first thing we're going to do is set our red plastic circle on top of the stick and post. And actually, you can follow along with your handout here. We're going to then, this larger red circle is going to represent the 2s orbital, and the smaller blue circle will sit on top of that, is going to represent the 1s orbital. In addition, we've got a couple of slots to indicate the presence of p orbitals, and this is the tricky one. We can insert into the slots in the crossbar one of the teardrop-shaped p orbitals pointing upwards, and on the other side, another teardrop-shaped orbital pointing downwards. So we've got a green color-coded p orbital. This is the one that's oriented vertically. We can also use the slots in the large red circle to hold teardrop-shaped yellow orbital. So that might represent, let's say the vertical axis is the py orbital. So the two green pieces represent the py. The two yellow pieces here represent the px orbital. And then lastly, I'm going to insert a couple more teardrop-shaped p orbitals oriented 90 degrees from there to represent the pz orbital. So we've got the px, the py, and the pz orbital. And the point is, this takes up 3 dimensions in space. So now we're ready to start adding these teeny tiny black circles that represent electrons. And if you look at your lab report, we're going to be asked to draw both an electron configuration and an orbital model, make an orbital model for each of these elements, starting with lithium and then working across the second period of the periodic table. Okay, so remember, the small blue circle in our model is the 1s orbital. The larger red circle is the 2s. And the various color-coded yellow, pink, and green teardrop-shaped orbitals represent the px, the 2px, 2py, and 2pz orbitals. So lithium has, if it's neutral, 3 electrons. You can find lithium's box on the periodic table. If the atomic number is 3, that means it has 3 protons. You should have the same number of electrons if it's neutral. So I'm going to place 3 electrons, and I'm going to place the first 2 of them on the 2s orbital. So that is, I'm going to just add 2 small black dots to the smaller blue circle. And then I'm going to add a third dot to the 2s orbital, which is the larger red dot. Let's see if I can get this closer to the camera here. So I've got 1 electron on the red circle and 2 electrons on the blue circle. And then what I would do is I'd snap a photo of this and upload it to the lab report. The next element would be beryllium. Oh, and by the way, the electron configuration, if you've got 2 dots in the 1s orbital for lithium, it would be 1s2, and then 1 dot on the 2s red circle means that the configuration ends with 2s1. Now for beryllium, beryllium is atomic number 4. So we're going to just add 1 electron each time. So I'm simply going to take 1 more small plastic dot, and I'm going to place it also on the 2s orbital, which in this picture means that I'll have 2 dots on the blue circle and 2 dots on the red circle. I'm going to reposition this so it's a little bit closer. You can see better if I aim it down. Okay, there we go. So now we've got 2 dots on the red circle, 2 dots on the blue circle. My configuration for beryllium would be 1s2, 2s2. Okay, next element, boron. So this is atomic number 5. And at this point, when we get to boron, notice that it has a different position on the periodic table. So boron is across the transition metals, and we're in the P block. It's atomic number 5. We're going to start adding dots to the p orbitals. Now you can choose whichever p orbital you'd like that first electron to go in. In the case of boron, I think I'll put it on the green dot here. I'm going to add just a little stickiness to this. I'm going to just kind of stick a dot on the 2p, one of the 2p orbitals. Remember, there's 3 orbitals in the 2p sublevel. So my configuration for boron would be 1s2, 2s2, 2p1. So I would write up and down arrow in the box for 1s, and up and down arrow in the box for 2s. And then in any one of the boxes for the 2p sublevel, just put a single arrow, either pointing up or down, doesn't matter. Okay, that's boron. Now let's go to the next page. We're just going to cruise across the second period in the periodic table. We've got carbon next. So I'm going to take 1 more dot. Now remember Hund's rule. The only thing that's important here is if I place the first electron of the 2p sublevel in my green orbital, I'm going to want to put the next electron not in the green one. It could go in the yellow or it could go in the pink. I think I'll put it in the pink orbital. So now I've got an electron configuration that would have, for carbon, 1s2, 2s2, so 2 arrows in the first 2 boxes. And then in this next sublevel, I'm going to put 1 arrow per box, meaning I'm acknowledging the presence of 3 different p orbitals. And of the 3 p orbitals that exist, the green one that's color-coded in the model has just 1 electron, the pink one has 1 electron, and the yellow one has 0 electrons right now. Next element, nitrogen. We're going to add yet another single plastic dot. And this one has to go in whichever orbital has not yet received one in the 2p sublevel. So I've not yet put an electron in the yellow color-coded orbital, so it's going to have to go there. This one represents nitrogen. So again, 1s, 2 electrons there, so 2 arrows, 2s2, so 2 arrows here. And then within the 2p sublevel, 1 arrow per box. Next element, oxygen. In oxygen, we're going to have to double up electrons in one of the 2p sublevels. Doesn't matter which one. I think I might go in order. So if I started with the green one, I think I'll put another dot in the green orbital that represents one of the 2p sublevels orbitals. So now I've got 2 dots on the green. And for oxygen, my orbital diagram would have 2 arrows in the 1s box, 2 arrows in the 2s box. And then one of the 3 boxes for the 2p sublevel would take 2 arrows, and the other 2 boxes would take just 1 single arrow, because we've got 2 electrons in one of those orbitals, 1 electron in another one, and 1 electron in a third one. And you can see where this is going. We have 2 more elements. We're just going to fill up our 2p orbitals. The next element is fluorine. So we've got 9 total electrons. That's 1 more than what we had previously. And I think I'll put this one on the pink sublevel. So now I've got, or the pink orbital within the 2p sublevel. Now we've got 2 dots on the pink, 2 dots on the green, and 1 dot on the yellow. In orbital diagrams, I'd put 2 arrows, an up and a down in the 1s box, 2 arrows, an up and a down in the 2s box. And then there's still room for 1 electron. There's no electron here yet. So I'd put 2 arrows, 2 arrows, and 1 arrow. Doesn't matter whether it's pointing up or down, as long as they're opposite each other. That's the key. The last element that we're going to consider is neon. Neon is atomic number 10, and importantly, it's a noble gas, which means that the 2p sublevel is completely filled with neutral neon's configuration, and that's why it doesn't like to bond with anything else. So this last electron is going to go in the last space available. In my case, that's the 2p yellow sublevel, orbital within the 2p sublevel. My orbital diagram would say 2 arrows in the 1s, 2 arrows in the 2s, and then all 3 boxes of the 2p sublevel would take 2 arrows, an up and a down. And again, what your classmates are doing for this lab is they're just snapping a photo of the orbital diagram, or this orbital model, after adding 1 electron apiece. Thanks for your good work, and we'll see you for next lab.